Okay, guys, let's just review what we did. All right, our logic. So we need to do ek elements to keep. Then we go to L1. Then we do L2. All right, because L1 depends on this guy, L2 depends on L1. Then we go to L3. Before all these, we check it logic. All right, to see if we got everything right. The logic says to us in which blocks we can break the code, they are independent or not. So we did that. Then we did ck, which is done. All right, we put the test code, everything is right, is working. So now let's go to L1. Okay, guys, this is the way that you can organize your code. All right, so when you finish ek, one thing that I suggest to you, if you do not have enough time to start one block and finish it, leave it for other time. All right, if you can start, of course that you can, and leave to finish other time. The reason for that is that when you start, you have the whole logic in your head, the solution in your head, so it's easier if you start and try to finish at the same time. All right, the same day. So if you break, for example, I start L1, all right, and it's going to take all this time from me, and I stop here and I come back tomorrow, I might not remember here, or something that I have to remember to do here, I might not remember the next day. So I have to review everything, and this is not good. All right, so try to have some time to start and finish L1, the same for L2 and L3. Okay, so let's go to L1 now. Let's review what is L1. L1 consists of all members of L which are part of elements to keep, preserving the original order. Preserving the original order. What does it mean? Let's see the test case. So here I have L elements to keep. All right, so L1 660. All these elements are from L, and these elements is inside the elements to keep, and it is in this order 660. Okay, all right, so let's see the next test case. So 4 2 4 2 14. So in L I can have only elements who are 2, 4 or 14. I can repeat because the first test case can be repeated. All right, so 4 is here and is here. Okay, 2 is here and is here, and 14 is in the last one, so I can jump also. All right, so we learned two things. One is that L1 can have repeated elements, and also that I can jump elements of L. So if I understood well, the way to do this is for each element of L, I check if this element is in L1. If it is, I append to this list. So let's do this here. So I have L1. Okay, L1, which in the beginning is going to be empty. Okay, these ones are already calculated. So if I do a for loop here, so for each element in L is already a tip how to solve the code. So I get the first one, 4. 4. Then is 4 in elements to keep? Yes. So I append to L1, 4. Then I go to the next element, 2. If 2 is in L1, append. If 2 is in elements to keep, append to L1. So 2. Finished. Then the next element, 8. if 8 is in L1, in elements to keep, append to L1. No, it's not, so I do not append. 3 is not here, do not append. 15 is not here, do not append. 14 is here, so I append. 14. Okay, so this logic worked for this test. Alright, let's see for this test. The first one, 6 is in here, yes, append. 6 is in here, yes, append. 0 is in here, yes, append. 4 is not in elements to keep, do not append. 8 is not append. Okay, two test cases already worked. Look like that our logic is correct. So let's check now. 4 is in here, no. 0 is in here, yes, append. 3 is in here, append. 3 is in here, append. 4 is not in here, do not append. 0 is in here, append. 1 is not here, do not append. 3 is in here, append. Work it. Let's go to the next guy. 5 is not here. 3 is in here. 3 is in here, append. 6 is in this list, append. 5 is not here, do not append. 0 do not append. 0 is in here, append. 0 is in here, append. 2 is not here, do not append. 5 is not here, do not append. Okay. Here's the same. So 6 in here, no, don't append. Then we append 0, 0, 4 not here, 8 not here, 7 is in here, 6 not here, 4 not here, 7 is in here, append, 5 is in here. So look like that our logic is correct, okay? I won't test the other test case because they might be too big, alright? We test for like 80% of the test case, and also I know that this logic works, okay? So, but for you guys, keep doing up to the end of the test, alright? Because some test case might have something that your logic is not prepared for that. So if your logic is not right, your code will not be right. So now that we got the logic right, let's start coding. So def let's put a good name, generate L1 from L and elements to keep. Alright, giving good names also, if you come to the tutor class, also helps me to help you, okay? Because if I read this function, generate L1 from L and elements to keep, receives L elements to keep, I already know what is the function about, alright? Usually, when I get a new function from someone, I usually see the input and the return. The return is going to be here, what? So, L1 is going to be a list. I'm going to return L1. Okay, alright, I understood. So, when you come to tutor class, try to separate your functions with a good name. Put the inputs, very well defined output, and also test case, because if your code is not passing in some test case, I can help you directly and already know what is the error, the line that the error is, everything. Alright, so let's change the name here. L, let's get the first guy. The first guy here, which is this one, elements to keep 06, 06. So elements to keep is going to be this guy, and the answer is 660. 660.